In tonight's lesson, you're looking at powers and exponents. So as you look through, as you watch the video, you're going to be looking at our order of operations and evaluating expressions and powers. As you are working on this, the vocabulary that you're filling in your notes is evaluate, to find the value of an expression. You usually want to get this as a one number answer. One number answer. So as you simplify things, you want to get it down to one answer. You don't want to have parentheses. You want to make sure it's simplified. You already should have subtracting integers we just talked about. Make sure you write down our definition. Subtraction changes to adding the opposite. So if you haven't paused the video, if you need to write that down, always we need to change subtraction to adding the opposite. Power, base, and exponent. Those three you're going to see on this next slide coming up. So as you're looking at that, and the order of operations, I know most of you already know that. If you want to think of your PEMDAS as you are looking at that. And we're going to talk about that, and you'll see that in your notes as we are looking at that. And again, just make sure that as you're filling these in that you write down all your answers. If you need to pause the video, do so. So subtraction always changes to add the opposite. And again, if saying it over a few times or saying it in your head will help you to remember that. It is not adding the negative, but adding the opposite is what you always want to look at. Power. A power is the product formed by repeated multiplication by the same number or expression. That's our definition of a power. The exponent is the number in the expression represented how many times the base is used as a factor. What does that mean? It means the whole thing is your power. The exponent tells you how many times the b is written. The exponent here is 8. B to the 8th tells us we have to have 8 factors of b. So our exponent is b, or is 8. The base of is what the factor is. It's what we're showing the repeated multiplication. It could be a number or an expression in this case. As you look at evaluating powers and how you read them, 5 to the second, 5 times 5, 5 to the second power, or 5, the other word we sometimes will use is squared. 8, here we have the base 8 with an exponent of 3. The repeated multiplication would be 8 times 8 times 8. 8 to the, we would say, third power, or 8 cubed. If we count the number of x's in our repeated multiplication, we have 6 of them, x to the 6th, x to the 6th power. So as we are talking about these, and I know you've probably worked with exponents before, that's what you're looking at. So if you're asked to evaluate, here's where we see that word evaluate. We want to get it down to one number answer. First, we might write it out as how many 3's do we have? 3 to the 4th means it is not 12. Be careful for that. But 4 3's multiplied together. Now most of you know 3 times 3 is 9, and another 3 times 3 is 9, and 9 times 9, a fact you probably know, is 81. If you are writing these as a power, now we don't really have this in our notes, so I just kind of want you to look at these, and maybe on one of the back pages or one of the pages where you have a little extra room, think about what this would be as a power. And what I'd like you to do is to pause the video if you need to and write the power. The first one would be 9 to the 5th as a power. Base and exponent make the power. 11 to the 3rd. T to the 2nd. We're not going to look at evaluating these too much and writing them in words, but I do want you to think 10 to the 3rd. 10 to the 3rd and 10 to any power is a nice easy one to remember. It's going to be, if we're evaluating it, 1 followed by, this is telling us the number in our exponent tells us how many zeros, so this would actually be 1,000. 7 to the 1, that's one that's always going to be equal to 7. So anything to the first power equals just that number. As you turn in your notes, if you look at this next page, it says reference lesson 1.2 and 1.4 order of operations. It tells you the page in your book, so if you need to look there. I can evaluate the value of a numeric expression using order of operations. all numeric expressions must be evaluated using our grouping symbols. What are the grouping symbols? It could be a parentheses, could be a bracket, could actually be our absolute value signs. All of those tell us to do inside of there first. Exponents is the second thing we're going to do. So anytime we have exponents, that would be the second thing we look at. Sometimes they refer to them as could be your third power, fourth power. Just be careful if there's something in the parenthesis, you do that first. Multiplication and division from left to right. Or I also like to think of it as division and multiplication. So it's whatever comes first, division and multiplication. If the division comes first, you want to do the division. If the addition comes, or the multiplication comes first, you want to do the multiplication. And the last thing you want to do in the whole problem is your addition and subtraction. Or, again, it could be your subtraction and your addition. Order of operations. Again, if you want to fill this in your notes from here, order of operations is simply going to be our grouping symbols. Powers, multiply, divide, add, or subtract. A lot of you probably think of PEMDAS. Another way to think of that is pandas eat mustard on dumplings and apples with spice. The reason we talk about it this way is that pandas can eat two separate courses, dinner and dessert. We would have our mustard on dumplings, that happens at our dinner, or dumplings with mustard. You could switch those. So pandas could eat them either way, dumplings with mustard or mustard with dumplings. This comes from the book. If you are looking at it, Math Doesn't Suck. If you haven't looked at that, check it out in the library. It's kind of an interesting one for most of you that you might find. How do we evaluate our powers? Inside our parenthesis, and this is what I'll have you do as you do your worksheet. You need to show me your work. 7 minus 3 is 4. We're going to put 4 to the third. I'll ask that you show your work below the problem. Subtraction changes to add the opposite, so plus negative 28, plus at the same time 8 to the second. 8 to the second is 64. We are now going to take 4 to the third. Remember, 4 to the third is 4 times 4 times 4. 4 times 4 is 16, times another 4 is 64. 64 plus negative 28 plus another 64. If I'm looking at this problem, we have a nice property in addition called the commutative property, which lets me switch the order. So this problem, I could actually switch the order and put 64 plus negative 28. Adding the two 64s, I have 128. This makes it a much easier problem, plus negative 28, instead of going from left to right, and our answer is 100. If you would right now take a look at this problem, 3 plus 2 to the fourth squared divided by 3 to the second. Pause the video and see if you can solve this one, and then I am going to show you, but pause it at this point. Here's the work. 3 times 2 plus 4 gives us 6. 6 to the second power divided by 3 squared. Should we now be multiplying? Not yet. We have to get rid of our exponents. 3 to the second is 36, divided by 3 to the second, which is 9. Now, if you look at this problem, as we are doing this, what we are looking at is 3 times 36. If we multiply 3 times 36, and again, some of you, if you don't know your multiplication facts or it helps you, remember, you can multiply it out this way. 3 times 6 gives us 18. We want you to get away from using the lattice if you're using that. 3 times 3 is 9 plus 1, so we have 108. We're going to take 108 and we are now going to divide it by 9. Someone said, should I be using my calculator? Here's another way of thinking this problem at this point. If you had 3 times 36, this is the same problem, divided that whole thing by 9. Now why would I do that? The reason being is that I know 3 goes into 9 3 times and 3 goes into 3 once. I also know that 3 goes into 36 12 times. And if I put in my calculator 108 divided by 9, I also get the answer 12. This is your guided practice that I would like for you to write down at the bottom of that page of notes. 6 plus 5 to the second plus 7 minus 5 to the third. 15 plus 9 minus 2 to the second, that whole quantity, minus 5, and pause the video if you need to. The other thing is, tomorrow in class, we want to make sure you have your calculator. So be sure to have your calculator with. Why? As we look at our calculator, I want to make sure you know how to use your calculator. Some calculators have a caret key for a power. Other calculators have a y to the x. And anytime you're using the squared key, a lot of you are actually going to have an x squared key. So be sure you have your calculators with. Have a nice night, and we'll see you tomorrow.